Thank you. When was it? October of 2014, we started work on our first Swift app. As Matthijs said, that was PostNL for the Dutch postal services. And we ran into a lot of issues, crashing compilers, missing libraries. It was rough. It was different from Objective-C. One of the things we ran into was parsing JSON we got from the server. And to solve that, we created a code generator. So that's what this talk is about. Quick question, who has done anything with JSON and Swift? And who has used any libraries to do that, like Object Mapper, Swifty.json? And who has enjoyed the experience? Yeah, that's a lot less. So I haven't really enjoyed the experience, but I've tolerated the experience. So that's what this is about. This is roughly the outline. First, I want to talk about why it is so difficult, why so many people lower their hands when I asked, have you enjoyed the experience? Talk about Apple's solution, NSSerialization. Talk about two libraries in particular as examples of how, and then talk about JsonGen, that's the library we've created, or the code generator. And then talk about something more practical when we use it. So this is some JSON. I hope the fonts are visible. Yeah, this is some JSON, and here's a Swift struct. And the whole talk is about getting from there to there, which doesn't seem that hard. There's a list of posts. Each post has a title, and which is a string, and an is published Boolean, which is reflected here. Why then is this such a problem? Well, JSON is very dynamic, and Swift is not. Swift is very static. So JSON can be completely messed up. You can have a null in the title, which won't fit in here because it's not an optional title. The field can have the wrong name. Title can be of the completely wrong type. This we get sometimes. And then the backend people say, but it's saying false. What are you talking about? Yeah, so going from there to there, that is a bit of a problem. In this case, not really a solvable problem. So first off, JSON-serialization. This is how you get started. You have JSON-serialization. You can say JSON object with data, pass some NS data, and then you get back JSON as any object. It can also fail if the JSON is not valid JSON, if you're missing a bracket or a comma is in the wrong place or something. Then the JSON doesn't parse and it throws an error. In real apps, we handle all these edge cases, but in talks, we don't. So we just assume it works. Same goes for what's coming out of it. So JSON is an any object. It can be anything, but according to the documentation, it's a dictionary of string to any object, so we can cast it and then continue on working on the dictionary. Otherwise, print an error, but again, let's assume it just works. And then finally, getting to the data which we wanted. This is how you get data out. Yeah, take the dictionary, give it a key. We want a title, and then again comes out in any object which we force cast to a string, assuming it will work. Same goes for the is published, which comes out as an NS number, which we then have to take the Boolean value of. This is how JSON-serialization works. And then finally we have the two fields which we can give to the post constructor. And Swift is nice enough to generate the post constructor for us because we didn't have to write it, so that's nice. But this was the original JSON. It's actually an array, so let's get, now we have to type this. Take out the posts, force cast that to a list of any objects, iterate over that list, each item force cast that to a dictionary, and then take each value and put it in a posts array. So this is all the stuff we need to do using NSSerialization, NS-JSON-serialization to parse the JSON into a list of structs. I have some problems with this. These are the problems. One, there's a lot of boilerplate codes which you have to type, and you have to type it each time for each type. This only handles the decoding of the JSON. I sometimes want to post back JSON to the server, so I have to write a bunch more code to post it back. I have to manually maintain names. So all these bits here are names which I have to maintain and have to match with these names and these names. And I can't make any errors in there or typos, because then, well, it won't work. Also have to manually maintain types. So all these casts here have to do the right casts. None of this is checked by the compiler. So that's a bit annoying. And error handling, again, in this example, I didn't do any error handling. So even if this is all correct, I mean, this matches what we assume is correct, but sometimes the server suddenly starts sending the wrong JSON. And then this would crash. So to prevent that, we have to write a whole bunch of checks, if-lets, or guards, write even more code. So these are the problems we want to solve. We aren't the first people thinking of solving that. There's a whole bunch of libraries, even more, but they fell off. Yeah, you may have heard of some of them. I tried them all last week, and with this single example. And I want to talk about two of them. The first one is Argo, which is the first JSON library I saw, and tried in Swift. Was out of beta, it's 1.0, but it kept crashing the compiler, whatever I did with Argo, and I don't think it was Argo's fault. So we have these two structs, the post struct again, and now I've created a blog struct which has a list of posts. And for Argo, you have to implement a protocol, and we can do that in an extension. The protocol is called decodable. You have to define a static decode function, which takes a JSON and returns a decoded post, and then or a decoded block. So that the type signature is easy enough. This is well, that's how the library works. It has a whole bunch of custom operators, and you need to do the right ones. So this is 1 bar. This is 2 bars. This I think it's correct, but yeah. So you have to know all this, how this works. This queries the initializer, and then you have to pass in all the values, and it checks in type inverse, and it all works. Yeah, okay. But now it doesn't crash anymore. With Swift 2, it runs. And this is how you can use it. So you can parse the JSON, give it to the decode function we just defined, then it returns a decoded block, which we can case switch over. It's either a success or a failure. In the success case, we can store the value in the post array, and in the failure, we just end. We get an error, and these are two examples of errors you can get. So you can either get a type mismatch, expected a string, but we got a number, or a missing key if some value is missing in the JSON. So this you can use. In production, we want to have error logging. So if there's something wrong with the server returning the wrong JSON, we want to log these errors. So it's nice that we can get nice errors. Except we only get the first error that occurs. So if there's 2 errors, we only get the first one, because then it immediately quits with a failure. So let's look at the problem checklist again. Lots of boilerplate code. Well, it's a lot less code than we had to write with the NS-JSON-serialization, so that's nice. Although, yeah. It only handles the decoding, not the encoding, so that's not so nice. If we want to send JSON to the server, we still have to write a bunch of more code. Still have to manually maintain names, so can't have any typos over here. That's not so nice. Don't have to manually maintain types. These are all typed invert. All these operators have the right generics and stuff, so we don't have to write any types, which is very nice. And the error handling is also available, so that's good as well. Another library is Mapper from Lyft. This one, we also need to implement a protocol called mappable. And there we have to create a custom initializer, which takes a mapper value, and it optionally throws if it can't initialize the type properly. So in this initializer, we need to set all the fields. So we need to set the title and the is published, and we can use the map.from function, which returns a value of the correct type or throws an error. And we do the same for the blog posts. And then we can use this like so. We can call this new initializer block using the mapper of the JSON, and then we either get back a block value, which is nice, we can save it, or it throws an error, which we can log, and it throws the error called mapper error. This is the exact error you get. And if, for example, you forget to write this mappable here, like I did last week, you can spend half an hour figuring out why it says mapper error when everything is correct, except it wasn't all correct. So, yeah, problem checklist. Beginning with the last one, the error handling is not so nice. Don't have to write that much boilerplate compared to the NSSerialization, so that's good. Still only decoding, not encoding. Still have to manually maintain all the names. Have to write title, is published. Don't have to manually maintain types, which is good, and not very good error handling. Now, finally, JsonGen. In JsonGen, you can use like so. We call the decode JSON function, static function on blog, give it a JSON, and it returns back a block from which we can store the posts, or it throws an error. Now, where does that function come from? Well, it's a code generator. JsonGen has an executable called a command line tool called Swift JSON Gen, and a library called JsonGen.swift with some basic decoders and encoders for things like ints and strings and booleans, as well as an JSON decode error enumeration when the decoding fails. This is how you can use it. Say you have a file called blog.swift, you call Swift JsonGen on the file, and it creates a blog plus JsonGen.swift, which has the generated encoder and decoder. This is the sort of the structure of the generated file. For each type in the source file, it creates an extension with a decode JSON function, which takes a JSON any object and returns a post or a blog, or it throws an error if it can't decode. As well as an instance function, encode.json, which uses self to get all the fields, and then it returns a dictionary, which you can then pass on to NSSerialization to create a JSON string from. So this is the code you write, actually, you yourself write. And then the error handling. This is an error that can be thrown, and it has two features I like. It has it collects all the errors, so it doesn't stop at the first error it encounters, but collects them all, and it shows you the path to the error. So at the top level, there's one error in the blog struct. In the post fields, there's one error in the array. At the first element, the index 0, there are two errors in the post struct. The first error is for the title field, the value is not the expected type, and the second is published field is missing. So again, looking at the problem checklist, don't have to write any code anymore. Both an encoder and a decoder don't have to maintain anything, and it has error handling. So that's nice. It does introduce some new problems. It is a code generator, which I don't really like. And it's a new tool, and it's written in Node.js, so you have to have npm installed. So yeah, that's the downside of it. I want to show you something, which is here. Yeah. So this is the source file. This is very white. Yeah. Adjust your eyes. This is the source file we saw before. And now I switch to black. Boom. Here's the very small, but I'll throw away the generated code from before. And let's regenerate it. Now you can see file is missing. It's red now. Swift JsonGen block.swift. And now it has generated this file. And I won't take you through all of the code because there's a lot of it. And it's all generated. But the basics are it checks some initial stuff and then throws an error. And then it collects all the errors that occur. It tries to parse all the fields from the dictionary. So the same stuff you saw before, but now all generated. And it collects all the errors, and then at the very end it throws all the errors at once, or it can return the generated post. So this is the basic structure of JsonGen. Yeah, I want to show you an example of a basic app we built. One of the apps we built a couple of years ago was 9292 for the Dutch public transport. And I recreated the suggest feature, which suggests you location names. Like for example, Amsterdam, you get some suggestions, or Rotterdam. Yeah, so this is the recreated struct, or recreated example. And the way it works, it calls a API. So this is the API which we can call, and then you can see it returns JSON. What it returns is an object with a field locations, which has an array of objects in it. Each object has an ID, and a type, and this one is of type station. It has some other fields, station ID, station type, in a place. But if we take another example, this is a train station, Lunteren, which has an ID. But if we look at the next result, this one returns the place Lunteren, which doesn't have a station ID and a station type, and it even doesn't have a place. So this station is in Lunteren. Lunteren itself isn't in a place. And here we have a point of interest, a POI, which also has some other fields again. So if you go through all this and write a struct for that, this is what you get. We have some suggestions, which is an array, and then we have a location, which has three fields, ID, type, and name, and which aren't optional, and a whole bunch of other fields which are all optional. And now if we look at what this user interface is, if we want to create this, this icon is the type, but this isn't even the name. If we take, for example, well, no, can't type. This is, whoa. And now I locked it, I think. Anyway, don't know what I did there. So it's a big step to go from this this JSON with all the optional fields to this user interface, which has a whole bunch of logic of what string is shown here, what string is shown here. There's a comma here because it's a foreign place. It shows you the name of the place and then the country, but it only does so for foreign countries. All that logic has to be written somewhere, which is the point of the app, to map from this source JSON to a nice UI. But I don't like doing that on this structure, because this is terrible. Can't really. You have to write if-lets everywhere to be able to handle this. And if you look at this, you think, who comes up with this? I mean, this is stupid. I can tell you who came up with it. It was I. So 4 years ago, I created the API. And this is the documentation of the API. And it says the location data type is a discriminated union of 9 possible constructors. And it lists all the constructors. So you have a station, and for stations, you have a station ID and a station type. It even shows the optionality. So a station has optionally a location, a let long location. A stop has some other fields, and a point of interest has some other fields, and on and on. So this is all documented, what this all means, but this isn't in the JSON. This is a separate document you have to read. But as a Swift developer, you might look at this and think, hey, this looks a lot like enums. But there aren't enums in JSON, so that's why it's all in documentation. But in Swift, we can create an enum for that. So that's what I did. I've created a location enum, and it lists all the cases. So there's a station, which has a type and a station code, and a stop, and a point of interest, and all that. And none of these fields are optional anymore, because now we know in the case of a station, we have guaranteed a station code. So this is a lot nicer encoding of the data. And then if we look, for example, at the cell, this is all the code that there is in the cell to fill all the fields. And then the real code is, of course, in the in here. This creates the title of a location, but this can work on do a case switch. And then pick the correct case, and now we don't have to check any optionals anymore. So this is really nice code. It matches the intent. Yeah, so that's the reason for creating the location. And then to go from here to here, I've written a mapper by hand, which is this one. I do a case switch on the JSON type and then create all the different cases. So this is a failable initializer on the location being initialized by the location JSON. So that's basically it. To recap, this is JsonGen. Oh, how do we? Yep. Features are it creates a encoder and a decoder code generator, works on both individual Swift files as well as whole directories. It can handle type aliases, supports primitive types, but also nested types where you're nesting one type in the other, custom generics. You can create your own encoders and decoders if you want to differ from the generated code. And you can even keep part of your data structure untyped if you don't know what its structure is and just want to have the any object back. Yeah, that's it. If you want to get it, here's how to get it. Thank you. Any questions? Yes.
I was wondering if you don't want the exact key in the JSON to map to the property. So if you want to have a kind of mapping you want is underscore published in the JSON and is published with camel case in the thing. How do you manage that?
Yeah. So there's two ways really. One is you create a custom encoder and decoder, so you can do all the code by hand. The code generator will check if you have a custom decoder. In that case, it won't generate anything. Or, like in the example here, I wanted to have completely different types, and here I renamed station ID to station code, that sort of thing. So then I do it in the mapper there. Other questions?
Which is the first?
Sorry?
Which is the first mapper here from your presentation?
The fastest.
Fastest.
Oh, fastest. I haven't looked at anything, except that I haven't tested it. I assume generated code will be fast, but that's just an assumption. Other questions? Yeah.
The only minor downside would be that you have to generate the decoder and encoder every time you change the structure, basically.
Yes.
So, but it's rather minor, right?
Yes, it's one. Yeah, running one command.
Okay.
Yeah, in our products we even have a script that runs a command. So you can just put it in a hook or whatever you want.
Okay.
Okay.
Yeah.
One more question.
This trick with the enum.
Yeah.
Do you intend to also put this in the code in the generator?
No, this is really domain specific. What you're looking at here. So, I've the fact that I can look at this type field is really specific to this one API. Other APIs might have different names and fields, so it's really domain specific knowledge, which I happen to know by reading the documentation of the API, but there's no generic way of knowing which field means what and which fields are optional and not optional.